Positional encoding. Let's see. Transformer models are very popular, and positional encoding is one of the things that make them work along with self-attention. Now let's see how positional encoding works. So why do we need positional encoding or positional embeddings? The challenge is when we are working with models such as transformers, or even when we use convolutional neural networks for text, there is no inherent position information that captures the relative position in the sequence. So we are giving sequential data, and we need to capture the inherent position in the sequence if we are not using a recurrent neural network. In a recurrent neural network, the order is automatically captured because you have connection from one token to the next. But what if you don't use an RNN, right? So how to capture the sequence information? Because the self-attention mechanism itself does not give any importance to the sequence information. What we do is we try to make the sequence information a part of the input embedding by first coming up with positional embeddings or positional encodings. The idea is if you have a sequence of tokens like this, she likes my book, each of these tokens gets an independent positional encoding, which is a vector that is unique to the position. So none of these four vectors, that for 0, 1, 2 and 3 should be the same, right? That's one of the requirements that we have. And that way, if we have these four vectors that give an indication of the position, that would actually help us identify the position in the sequence information. So how do we compute positional encoding? So typically we take the input embedding to the model itself, which captures the semantic meaning of the word. That's what we hope the input embeddings do. And then we also add another vector which represents the position, right? And we want, what are some properties that we want for this vector? So we want this positional embedding to be unique to the position of the token. So that's the first thing. We don't want this to be, the same for position 1 and position 3. That doesn't make sense, right? We do not want any semantic meaning such as, position-based preference order. For example, if I have 3 tokens in my sentence, can I have the embedding as, like 1, 0, 0, 0, 2, 0, 0, 0, 3 and so on? That's not great because it might give some kind of a notion of position 1 being more important than position 2 and so on, or higher in value in some sense, right? We do not want the embedding to be dependent on the sequence length, right? So basically we do not want to use, so whatever I described earlier is also based on the sequence length. So we do not want the embedding to be based on the sequence length, and irrespective of the kind of sentence I come up with, we only want it to depend on the position of the token, right? That's what we want here. So the Transformers paper does it this way, and there are multiple ways to do positional encoding perhaps, but the Transformer paper does it this way. So for all the even positions, it takes sine of position divided by 10,000 to the power 2 into I by d model. So here POS is the position, d model is the dimension of the input vector, right? So basically if I have let's say what is the dimension of my input embedding? So if I have 512 dimensional embedding, then d model will be 512. What is I? I is the position within the embedding vector. So we have what we saw here is P00, P01 and so on. So I is the position within this embedding vector, right? So now basically this is how this is a formula that they use for positional encoding, and what this guarantees is that each of the vectors is unique, and it also satisfies the properties that we saw earlier. So one of the reasons they actually play around with the argument to the sine and cosine is because we want to make sure that things do not repeat, they are unique and so on, and doing so, like making it a function of position and I, helps us with some of those properties. So to summarize, we looked at what positional encoding is, why it is helpful to preserve sequence information, and we also saw how positional encoding is computed in transformer models. Thank you.